Okay, today we're going to be adding fractions with unlike denominators. Yesterday in class we worked on adding and subtracting fractions, but they had like denominators. And if you'll remember, when the denominators are the same, you don't have to do anything but add the numerators or subtract the numerators and then put that over the denominator when they are like. Today, our biggest thing I want us to remember is this fact I have here at the bottom. You cannot compare, order, add, or subtract fractions with unlike denominators without finding a common denominator first. So today we're going to be working with finding common denominators in order to add fractions. So if you look at this first slide, it says find a common denominator and solve. Now, your original problem was 1/2 plus 2/9. And I want to just show you a really quick way to find a common denominator. If, let's say, you don't know what 2 and 9 both go into, a quick way you can do that is to basically list all the multiples, or not all of them, but list several multiples of 2 and 9. So when I say multiples, I mean that number times 1, times 2, times 3, times 4. Those are going to give you multiples. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, 2 times 7 is 14, 2 times 8 is 16, 2 times 9 is 18, 2 times 10 is 20. Now I went all the way through 10 here. You don't have to do that all the time, but I think you're going to understand why. Okay, so my number's 9. 9 times 1 is 9. 9 times 2 is 18. Now if you'll notice, the common factor or multiples that they have are 18. That's the least common multiple. So I can use that to change 1/2 plus 2/9 if I change them both into 18ths. Now I'm sure most of you knew that 18 would be your common denominator, but wanted to show you how to make this a list if you get stuck. That's just a quick way to do it. So basically what I did was, to get from 2 to 9, I had to do, 2 to 18, it's times 9. So remember what I do to my denominator, I have to do to my numerator. 1 times 9 is 9. How did I get from 9 to 18? It's times 2. What I do there, I have to do here, and that's 4. Now I have like denominators, which we worked with yesterday, so I'm just going to bring it over. 9 plus 4 is 13. So now I know that 1/2 plus 2/9 equals 13/18. Okay? Let's try this problem. This is going to be a really quick lesson today, because basically if you can find common denominators, you can add fractions together after finding common denominators. Okay, so I have 3/4 and 7/10. Let's say I don't know what 4 and 10 both go into, so we can list some multiples. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. Ooh, because this is 10, I know 20 is going to be a multiple. 10 times 1 is 10, 10 times 2 is 20. Notice they have 20 in common, so 3/4 plus 7/10. Let's change them both into 20ths. How did I get from 4 to 20? Times 5, which means I have to do times 5 up here. 3 times 5 is 15. Remember, all we're doing here is we're making equivalent fractions. 3/4 is the same thing as 15/20. It's just using a different fraction. How did I get from 10 to 20? That was times 2, which means I have to do it here as well. 7 times 2 is 14. Now, because I have like denominators, I'm just going to bring it over. It's 20ths. 15 plus 14 is 29. Now, when you look at that, I'm hoping that you see that that's an improper fraction. So we're going to change that to a mixed number. 20 goes into 29 one time with 9 left over. So your final answer would be 1 and 9/20. So 3/4 plus 7/10 is 1 whole plus 9/20 of another whole. Okay. One more problem that I want us to work together. 5/12 plus 1/8. Let's think about 12 and 8. If you don't know automatically what you would want your common denominator to be, let's do some multiples. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. You can do as many as you want. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Oh, there it is. Look, 24. So if I want to change 5 twelfths and 1 eighth into 24ths, let's make them both 24ths. All right, how did I get from 12 to 24? I did times 2, which means this has to be times 2 as well. That would become 10 24ths. So 5 twelfths and 10 24ths are equivalent fractions. How did I get from 8 to 24? Times 3, which means I have to do times 3 here. 1 times 3 is 3. Because my denominators are like now, I'm just going to bring them over. 10 plus 3 is 13. So 5 twelfths plus 1 eighth equals 13 24ths. And I did not mention this, but I always want you to stop and ask yourself, can my answer be reduced? Because from now on, you're always going to want to put your fraction answers in lowest terms or simplified terms. 13 is a prime number, so we know that that's as low as it can go. All right, part 1, part 2, and part 3. Here's what I need you to do to show me you understand what we have just looked at. Work these problems for me. 2/3 plus 1/5. Show me what your common denominators are on this one. This should not give you any more trouble by adding one more fraction to this equation. And then down here, part 3. Just tell me, what equivalent fraction would you have to use in order to add 3/5 to 21 25ths? So tell me what equivalent fraction you would use to make them the same. Okay, so basically, this is asking basically what would your common denominator be for these two numbers, and you're going to obviously be changing one of them to an equivalent fraction so that you can add the other one to it. Okay, if you had any problems or don't really understand how we do this, like I said, basically if you can make equivalent fractions and you can find common denominators, adding fractions with unlike denominators is not hard. You just have that one extra step of making those denominators like before you can add to them. So please complete part 1, part 2, and part 3 on your notes very neatly and bring that to class tomorrow ready to work. Have a good evening.